Wednesday, May the 8th, 2024. Here we have the second video for Jack with US Steel. And we've gone over the setup on our first video. Now we're going to power the board. We're going to apply 24 volts AC. We have our red LEDs here. We got the phase loss. We have our green LED on. Let's go ahead and bring in our three-phase 240. The board is purposely inhibited. So one of the things we've done is we have our current limit at 100%, or our current limit at 0%, or voltage at 100. We're going to regulate current, and our current trip at 100%. Let's go ahead and enable Tony. Because the current limit potentiometer is at 0, our output is essentially 0. So let's go ahead and bring it high, and we'll see. So our AC voltage is 250, and I'm going to ask Tony to stop at roughly 260. Okay, that's close enough. We have 262 volts AC. At this point, based on the size of our load, our lamp load, we're using a 2 amp shunt. We have 45 millivolt across it, and our resistor network is giving us the 4 volts that we wanted to regulate at. SIG-high, it's 5 volts going from the regulator. So I can ask now Tony to reduce the current and bring it at let's say we have 45. Let's bring it to 30 millivolts, Tony, whatever that AC voltage turns out to be. Alright, that's good enough. That's close enough. So right there. So now that is 141 volts DC. Have the 30. The voltage feedback has also been reduced to 2.20, and our SIG-high is 4.1. And as you can see, the voltage is, the SIG-high is pretty steady. Our DC output is pretty steady, and our delay angle, the duty cycle of this at TP3, the blue channel, it's pretty steady too. Alright, so now let's go ahead and come down, Tony. Just bring it back to 0. Alright, our parameters are still the 250. That's a 240 line, but it's 250, and there's nothing we can do about it. Our output right now, it's negative. It's really because our delay angle, it's just too low. The duty cycle, it's low. The voltage feedback, it's again negative, and we basically have 0 voltage feedback. The minimum SIG-high, however, it's 1.3 volts. That's what we have, but yet that's low enough not to get any output. Now what we're going to do is we're going to change this, and we're going to increase the current limit to 100%. Oh, before you do that, Tony, bring it back, please. Can you bring the voltage limit to 0? So we're doing the opposite. Making that 0. Bring that to 100%. Alright, and now we have a little bit of an output, but we can still regulate. So can we start increasing? And let's stop at 150 volts on it, just for reference. Okay, that's good enough. So again, the 250. Notice that this 250 is pretty solid because the light, it's less than 2 amps, the current. We have 152, and again, it's just varying by a tenth of a or a hundredth of a volt, like by 20 millivolts. We're regulating steady voltage and current, or the delay angle. Again, it's solid. The duty cycle. Are you measuring duty cycle? Yeah, there you go. 65.3. Yep. The phases are 60.2 degrees, but it's 65.2, 65.3. And our it's proportional. It's 4.23. So we can voltage regulate, we can current regulate. It's pretty solid, and we don't have any issues now that we have our shunt in the opposite leg of a rectifier. So this is the end of this video.